This part is the charging process of the capacitor, and this part is the discharging process of the capacitor. To observe the charging and discharging of a capacitor, you first need a reliable oscilloscope, a power supply capable of outputting a regulated DC voltage. You also need to build a simple circuit. This is a switch used to control the charging and discharging of capacitors. This is a 470 microfarad capacitor. The accompanying resistor is 1500. One of them is used in series in the circuit as a current-limiting resistor for charging the capacitor. The other is used in parallel as a resistor for capacitor discharge. Next, I will explain how to connect the wires. We all know that capacitors have positive and negative poles. The section with the gold vertical stripe is the negative pole of the capacitor. We receive the negative pole of the power supply. Connect the red wire to the positive terminal of the power supply. The positive and negative terminals of the probe are also connected to the positive and negative terminals of the capacitor. The power supply output is set to 12 volt. Turn on the switch. Press the run-stop button. We can then observe the entire charging process of the capacitor on the oscilloscope. It should be noted that although our power supply outputs 12 volts, however, the two resistors are connected in series, which also constitutes a voltage division relationship. Therefore, the capacitor charging voltage captured on the oscilloscope is approximately 6V rather than 12V. Looking at the waveform on the oscilloscope, we can see that at the beginning, the voltage across the capacitor rises the fastest. As time passes, the rate at which the voltage rises becomes slower and slower. Until the capacitor is fully charged, the voltage remains constant, and the waveform becomes a horizontal straight line. This indicates that when the charging voltage is constant, the charging speed of the capacitor is fast at first and then slows down. The voltage curve resembles a gradually slowing uphill slope, which is characteristic of capacitor charging. Turn off the power switch, and we will now begin capturing the capacitor discharge process. Observing the waveform on the oscilloscope, the voltage across the capacitor initially drops at the fastest rate. The rate of decline then slowed progressively. Until the voltage becomes 0 volts, the waveform becomes a low-level straight line. It can be seen that the speed of capacitor discharge is also fast at first and then slow. So, what kind of waveform would we get if we continue to charge and discharge? It can be seen that we have now basically formed a simple oscillation. So, in an actual circuit, we can add a transistor to control the charging and discharging of the capacitor.